Okay, today's lesson is 6.7, Solving Radical Equations. This is the last section of this unit, and so we're going to take something that you already should be somewhat familiar with, but you did do solving radical equations in Algebra 1, or at least have seen some basic solving of radical equations in Algebra 1. One thing that might be new will be obviously the introduction of cube roots. But other than that, I mean, it should seem pretty similar. And so we're going to go through it. We did a little bit of this last semester. So, like I said, today should be fairly straightforward. So, anyways, radical equations. So, radical equations are equations with radicals that have variables in the radicand or what's underneath, what's under the radical. Okay, so when you hear the word radicand, it's what is underneath the radical, and it's called our radical equation. So equations with radicals that have variables in their radicand, which is underneath the radical, are called radical equations, and that's be an S and M. An example of a radical equation is, something that looks like this: square root of x plus 4 equals 4. So you have something with a variable underneath the radical equal to some number or something, and so we can solve all of these pretty easily using the fact that square roots and squares and cube roots and cubes cancel each other out, much like we would use division when we have multiplication, or addition when we have subtraction, to cancel things out and solve for variables. To solve the radical equation, this is probably the most important part and where most people find the most mistakes, or they do the wrong thing here, and that is when solving a radical equation. There are three pretty straightforward steps here, but the first step is going to be isolate the radical on one side of the equation. So a lot of people will not do that. I mean, they will not. So like in the first problem here, they would try, because this is a square, they would try to square both sides before moving the 2 to the other side. Or here they might cube before they move the 1 to the other side. So you have to get the radical by itself first, and then do the opposite of that radical, which is to raise each side of the equation to the same exponent to eliminate the radical. So if it's a square root, you would square. If it's a cube root, you would cube, and so on. And then solve the resulting equation. So here's what this looks like. The one thing you're going to want to do, and we'll show you here in a second, is going to be this last part here, and that is to check your solutions. Believe it or not, when you get an answer of x equals whatever, sometimes one or more of those answers don't actually work. I know it seems weird. You solved for it. It should work. But because radicals have restricting domains, sometimes, because we can't get negatives in the radical, sometimes our answers actually give us a number that would produce a negative in the radical, and it can't work. So we're going to go through these and practice checking our answers, and hopefully it should seem pretty easy. So in number 1, we have to isolate the radical, so we need to divide the 2 over to the other side. Okay, and that'll leave the radical isolated of x plus 1 equals 2. Once the radical is isolated, now I can get rid of the radical by, since this is the square root, I would square both sides, getting rid of the radical, leaving us with x plus 1 equals 2 squared, or 4. We then subtract 1, and get x equals 3. Now that is our solution. We do want to verify that that solution does in fact work. So what we can do, there's a couple things that we can do, is we can put this into our graphing calculator, or we can just plug this in. So if I plug in 3 into the radical, 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. So this particular solution works. By plugging it back in and making sure that I get 4 equals 4, that works. So let's try number 2. Again, we need to isolate the radical, so I'm going to move the 1 over to the other side by adding 1. Okay. I get then the cube root. Don't forget that cube. It's very common for people as they move down the equation to forget that index. The cube root of 2x minus 9 equals 3. Since this is a cube root, I'm going to cube both sides. That'll get rid of the cube root, leaving me with 2x minus 9 equals 3 cubed is 27. Add the 9. 2x equals 36, and divide by 2. X equals 18. Now we're going to verify that that is in fact a correct solution, so we're going to plug this back in. 2 times 18 is 36. 36 minus 9 is 27. The cube root of 27, and you can put that in your calculator, is 3. 3 minus 1 is 2, which equals 2. Therefore, this checks. Okay. Here's where it can get a little tricky when you have variables on both sides of the equation. So first step is not going to change. Okay. The first step is I'm going to add the 1 to the other side. But with having an x on both sides, it definitely complicates things. So 7x plus 15. So I did isolate the variable. The variable is all by itself. Or sorry, the radical. The radical is all by itself. But when you go to get rid of the radical and you square, you have this entire thing. One of the biggest mistakes that kids do every single time, most times, is they just square both of these, making it x squared plus 1, and that's not true. You're squaring this entire side, so technically you need to put this in parentheses and square it like that. And that does not mean don't distribute the negative. You should understand by now, at this point in time, that x plus 1 squared is not x squared and then 1 squared. It means that there's 2 of them. So this is x plus 1 and x plus 1. Now this over here will get rid of the radical, leaving you with 7x plus 15. But over here you have some work to do. I have to do the double distribution. I have to do this times this, this times this, this times this, this times this, and get this all foiled out here. X times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. Equals 7x plus 15. Okay. Whew. I then need to move some things over. And this becomes 2x right here. So I'll just bring this over as 2x. But then I need to, with quadratics, unlike with linear equations, you would get the variable to one side, the numbers to the other. But with quadratics, if you remember with quadratics, you need to get everything to the same side. So both of these over here need to go over here. So minus 7x, minus 7x, minus 15, and minus 15. So now on this left-hand side, I'm running out of room here. On this left-hand side, I have x squared. You have 2x minus 7x is negative 5x. And then 1 minus 15 is negative 14 equals 0. Okay. We then would factor. You can solve that by factoring, or you can put it in your calculator and find the x-intercepts, or you could use quadratic formula. I don't care. Sometimes these are not going to be factorable, and that's a problem. So we might want to just get in the habit of using quadratic formula. But just for sake of time, this is factorable. There is a number that multiplies to be 14 and adds to be negative 5. Well, numbers. And that is x minus 7 and x plus 2. Those multiply to be negative 14 and add to be negative 5. If I set them both equal to 0, I will get x equals positive 7 and x equals negative 2. If you're confused about that, then you can go back to some of the solving quadratic lessons from last semester. But those are your solutions. Now we do need to verify that both of those solutions do work. So we are going to plug those back in and see. Now, one of the things that you can do is use your graphing calculator. Now, when you had linear equations like up here, it was real simple just to plug it in. It might be able to save time just by plugging it in. But when you get multiple answers here and you would have to actually put both of them in, it might be quicker to just put these in your graphing calculator. So I'm going to have my graphing calculator here, and what I'm going to do is I'm going to put the left side in for one of my equations and then the right side in for my other equation. So I go to y equals, okay, I'm going to do the first, let me clear that out. I'm going to do the first one, which is just x, like that. And then the second one's going to be this. So I have the square root of 7x plus 15. I do need to get out of this radical. If you have an older model, you'll need to close the parentheses at this point and then do minus 1 so that the minus 1 is not inside the radical. Okay? Now remember, where these cross will be solutions. So when we graph these, we have the line there, and then I have a radical. Remember that wherever these cross are solutions. So when we go to put these in here, we have solutions at 7 and negative 2. But when we look at our graphing calculator, do you see that there is a cross at negative 2? No, these don't actually cross at negative 2. They only cross over here at 7. And we can verify that by going second calc and going to intersect and just hitting enter, 3 times. 1, 2, 3. And there you can see that it crosses at 7. X equals 7. So, since it doesn't cross at negative 2, but it crosses at 7, on our answers here, negative 2 actually does not work. Okay? So only 7 is the solution. Okay? Now we're going to try that one more time. Solve the radical, get your answers, put the equations back or into your graphing calculator to verify which solution is correct, if any. There are cases where there could be no solution as well. So number 4, we'll try the exact same thing. Now in this case, the radical is already isolated, so I don't need to move anything. I just simply, because this is a square root, need to square both sides. Now, don't forget, this is in parentheses squared. And what that means is there's 2 of them, so negative x plus 2 twice. This will get rid of the radical, leaving you with just x minus 1 equals, I'm going to multiply this out. I get x squared, negative 2x plus 4. This combines to negative 4x. I'm going to move everything to the same side by subtracting x and adding 1. Subtracting x and adding 1. So I have 0 equals x squared. Negative 4x and negative x is negative 5x. And 4 and 1 is positive 5. Now here's a situation where this particular quadratic is not actually factorable. Over here we had something that was factorable. Now again, if you don't want to worry about whether something's going to be factorable or not, you might as well just do the quadratic formula every time. It's just, you know that it'll work every single time. So for this particular problem, again, it's not factorable, so I'm going to have to use the quadratic formula, which is the opposite of b, or 5, plus or minus the square root of b squared, which is 5 squared, which is 25, minus 4 times a times c all over 2 times a Now, just to sort of conserve time here, what's inside the discriminant, what's inside the radical, reduces to 5, so square root of 5 over 2. And then I'm going to create the decimal forms of these by doing 5 plus radical 5 divided by 2 and 5 minus radical 5 divided by 2. I get two answers of 3.62 and 1.38. So these technically are both of our answers, though we do want to verify that either of them, both of them, none of them work. So we're going to verify this. Now, obviously, this one would be a lot harder, a lot more tedious to try to just plug in. So we're going to look at our graphing calculator for this. So we'll pull on our graphing calculator. Y equals, clear these out. Remember that you put the left side in one of your y's and the right side in your other y. So I have on the left side just the square root of x minus 1. So square root of x minus 1. On the other side, I have negative x plus 2. Don't worry about what you did over here. You're putting the original in there. So negative x plus 2. Now, again, wherever these cross should be the solutions. Now, I don't know why I put it into y2 and 3. You don't need to put it into 2 or 3. You can use 1 and 2. It doesn't matter what two y's you use. So I just accidentally put it into 2 and 3. When we graph these, we see where they cross. There's our radical. There's our line. Ooh, this is going to be close. So it does look like it only crosses in one place. So I'm going to zoom in just to see this. Zoom in and see if I can see this a little bit closer. There's our radical, and there's our line. So it does cross right there, but you know what? I don't really know what that is. That's probably not 3.62, but let's verify. Second, calc, intersect, hit enter 3 times. Wait, where's my... I don't know where my cursor is. Oh, there it is. Okay, so find your cursor first and then hit enter 3 times. There it is, and it looks like it is 1.38. So it does not cross at 3.62. This is not an answer, and 1.38 is your answer. Okay, flip it over. We got a couple more, and these are where you would have to change the form into radical form first and then do it. I mean, we could take the time and actually solve these if you want to, but it's the same thing. So this is 1/2. So that is a square root. So that technically this is the square root of x plus 30 equals x. The radical is already isolated, so I could just square both sides. Well, then the right side's easy. It's just x squared. And then this comes over. So I get x plus 30 equals x squared. I simply just bring everything over. I'd like to avoid having a negative x squared, so you wouldn't want to bring this to the left. That would give me a negative x squared, which is kind of, it's just makes things more complicated. So I'm going to make this a positive x squared and move everything to the left, which is subtracting, or sorry, the right. Minus x minus 30 minus x minus 30. I have 0 equals x squared minus x minus 30. Now again, you could use quadratic formula for this, but you don't have. This is factorable. There are numbers that multiply to be 30 and add to be negative x, and that would be negative 6x minus 6 and positive 5. Negative 6 and 5 is negative x. Negative 6 times 5 is negative 30. I can then set those equal to 0 and solve, and I get x equals 6 and x equals negative 5. I could verify that using the graphing calculator, though. This seems simple enough that I could probably just plug this in. 6 plus 30 is 36. 30 square root of 36 is 6, and then I have x on this side as well. So it's 6 equals 6. So 6 does work. Let's try negative 5. Negative 5 plus 30 is 25. If I take the square root of 25, I get 5, but I don't get negative 5. So this does not work. Therefore, this is my answer. One more. This is the third power, which means that's a cube root. So this is technically the cube root of 3x minus 3. So I'm going to cube both sides to get rid of that root, which gives me 3x equals the cube root, or sorry, negative 3 cubed is negative 27. Divide by 3. X equals negative 9. I do want to verify that. So we do plug in negative 9 into here. Negative 9, 3 times negative 9 is negative 27. The cube root of negative 27 is negative 3. So this works. Don't forget to check and verify whether your answers are correct. You can use your graphing calculator, which might be quicker, especially in these longer, more complicated problems, or you can simply just plug it in. Either one works. Thanks. Let me know if you have any questions.